Hello everyone, this is Physics 101 and this lesson is on Coulomb's law. So let's ask first this question. How can objects move without any visible force acting on them? So from intuition, we know that if we kick a ball here, we apply a force on that ball will move in this direction. So you can see a visible force that causes this ball to move. But what if, say, suddenly you observe that this ball is moving in this direction without any force that is acting on it? How would you explain the motion of that ball? So there are forces that we cannot see but actually act on objects. These are called field forces. So an example of these are gravity or gravitational force, electrical force, and magnetic force. So gravity, you cannot see how gravity actually pulls down objects towards the center of the earth, but you know that it is causing objects to fall down towards the center of the earth. Now for electrical forces, which we will talk about later on, you cannot also actually see how, for example, you rub a balloon and give it a charge, and you see that your hair is actually sticking through the balloon. So there's no visible force, but you know that there is a action that is happening. For magnetic force, you know this very well. So you cannot actually see the force that is acting on, say, attracting or repelling magnets. So with these kinds of observations, how do we know that that these forces exist? So this is a question that has a very deep nature, and the answer to this is because of fields. And vice versa, the answer to how do we know that these fields exist is because also we observe that these forces exist. So it's like a circular question, but for the lack of any better explanation, these fields are the most suitable mathematical object in order to describe the existence of these forces. So what are these fields? So let's look into a specific example of an electric charge, a positive charge. So this positive charge sets up a field, sets up an electric field that is radially outward. And if we have a negative charge, this sets up a field that is radially inward. Now suppose that you bring these two charged particles together. You bring this positive charge and negative charge together. What will happen is that these two will attract each other. So this positive charge sets up a field that is attractive to this negative charge, and vice versa by Newton's third law. This negative charge is also attracted by the same amount to this positive charge. So this is the property of the electric fields. So these electric fields can either be radially outward or radially inward. So if you compare it to a gravitational field, so for the sake of comparison, you have a mass here. A gravitational field is always radially inward. So for example, you have another mass here. This mass will go towards this other mass. It will attract this other mass. So with this electric field, we can now explain Coulomb's law. So Coulomb's law is the force F, let's call it Fe for electric force experienced by a charge a charge Q due to the electric field E. So this is electric force this is the test charge, and this is the source field. So from our example earlier, if we have here a positive charge, it sets up a field radially outward, and you put in a, say, positive charge near it. So this positive charge will feel a force that is in the same direction of the source field. So this positive charge feels as if this electric field is acting on it on the direction of its force. So the result is these two same charges will repel each other. So what about if we have the same positive charge and instead of putting in, sorry, if instead of putting in a test charge of a positive one, we put in a negative charge. Use this color. We put uh, a negative charge. So the same thing will happen. This electric field that is set up by this positive charge will extend through and it will interact with the negative charge, and the force that will be experienced by the Coulombic force that will be experienced by this negative charge is equal to its charge, since this is the test charge. This is the test charge times the field. So since the test charge now is minus 1e times e, the force follows the direction of the e, but since there is a negative sign here, it will be the opposite, that it will be on the opposite direction. Thus, this minus charge will experience a force in this direction. So that is why unlike charges attract each other. So that is Coulomb's law. Fe equals Q, charge of the test charge, times E. So Coulomb's law can also be written as Fe equals K Q1 Q2 over R square. So sorry, this should be magnitude. So this is still the same equation. This is our test charge and our source field comes from this source charge. So this whole term is actually the electric field. So we can say that the electric field or the source field is equal to K KQ2 over R square.